what is this that we're making?
Well, we're going to make a motogripper. The original gripper had one part, a hand, a thumb, a castration band as a spring, and we used 2 zip ties in order to get the angle right. The motogripper has a palm and a backhand. We've replaced the rubber band plus zip ties with this nice little metal spring, and I'm going to show you how it all comes together.
What is this motor?
Well, the form factor is called N20A. Don't ask me why, but it's a $10 motor with a gearbox. They're available in a number of different gear ratios, which result in faster or slower speeds. And they're widely available. We haven't picked our favorite particular model yet. There you go. This is a pretty good fit. It turns out that while the design is robust to a lot of things, this particular small hole with slot seems to come out differently depending on the printer you're using. And so the model that we have actually provides you with a small, medium, and large, so that once you print it, you can see which one fits most snugly but doably on the shaft.
Basically, we have a motor, we have a battery, we have a bolt, and we have some 3D printed parts.
That's right.
What I don't see are any wires.
Well, that's right, and that's because we have discovered that we can use the lost art, the soon-to-be lost art of paperclip origami in order to replace wire, solders, and microswitches and logic circuits. All of these files are available as Tinkercad STL files.
So you did this in Tinkercad?
We did it in Tinkercad. And we're still using Tinkercad to dispense the STL files, but if anyone wants to do modifications, we'll be happy to provide a Tinkercad where you can actually modify the components themselves. In addition to the printable components, there are, as we've seen, a number of metal components, and the documentation actually provides live links to places where you can order these things. The very first thing we should do, actually, is to put the cam on the motor. I'm a believer in reducing your parts count by assembling subcomponents. One drop.
Does the cam, changing the size of the cam, affect also how the other parts?
Well, all we're changing when we look at these different cams is the size of this D-shaped slot.
Just the hole.
Just the hole, whose job it is to, right. And by the way, you do this with the stem, if you will, facing inwards to the motor.
You see that number there?
3.9 is a measure. I think it may be a measure in millimeters of the width of the shaft, but I don't remember what it really reflects. The motor fits into the chassis. The motor has a square end and a ovoid end, and if you look carefully, you see that this is the square end, and that these two contacts want to be side by side and snugged right up to this little blocking post here. Okay, so here we are. And now we're going to use 2 paper clips for 2 motor contacts. For the most part, we start with straight paper clips, and having done this a few thousand times, I can tell you that it's often easier to straighten the paper clips with your fingers so that you don't introduce kinks. But once you've done that, and that's, you know, roughly good enough. So that's 1, and that's 2. And the very first thing to do is to make sure that your holes are clear. Which is to say, when you're 3D printing, you may have little bits of grunge in here. And so I will tell you that you're going to want to be able to pass a paper clip into these square windows. And I've just confirmed that I can do that. And here's the square window on the other side. Little tiny square window right here. And that went in. Now, our job here is to go in through these little square windows and harpoon the little hole in the contacts. So here's a little square window. I go in. I don't force it, but I woggle it, trying to get it through the small hole in the contact. Now, sometimes, this is something I should have checked up front, the contact hole is a little too small for the paperclip, and that is the case. Sometimes you can address that just by cutting the paperclip at an angle,
Let's take out this
so it comes to a
contact
sharp
hole.
point.
What we're talking about is this little hole.
That's right.
You can see it at the very end there. The paperclip has to reach that hole.
That's right. It has to not only reach, you want it to pass through. So here I am now
Right.
passing it through, and because I sharpened it, most of it will go through.
Right.
Now that's adequate, but you know, you actually
Yeah.
would like it to go even farther through. And so then what you do is you take a razor, if you have to do this, which typically you don't. You take a razor or a file or sandpaper, and you just try to take a tiny, tiny bit of diameter off of the paper clip. I'm going to do the other one while I'm here, because I know I've got this problem. I'm going to sharpen the point. You should wear glasses while you do this work, because the clipping does indeed cause little bits of metal to fly into the air. Okay. And now I take my file and I just try to skinny it up a little bit more. Okay, so this goes in, we push it forward. I secure it with my thumb, I put this through, and I try to get it, there you go. It harpoons the contact, okay?
Okay.
Great. In this
Start
case,
second.
I now bend it this way and down into that slot. So now it's secure.
Okay.
Number 2, symmetrical, sort of. Go into this hole. Look to see if I've harpooned the contact, and I have. And in this case, we go forward. And because we can, I'm now going to go the next step, which is down, over, up. So now it's not going
So
anywhere.
we got the little loops around there.
That's right. And I can do the same thing here.
Right.
Down,
Let's see, actually, I'm not seeing it from your angle.
down on this ramp, over,
And it loops around
and up.
and up.
Okay? So this is now symmetrical, and it should even be secure. And one of the nice things about this particular process is that we can test this already. It ought to be the case that when I touch these 2 contacts to the motor, okay? So we're on our way. Now it's a good time to put down the roof, because
Okay.
that will secure everything. The roof has a flat and a curved, so you want to get that right. So we've got this little hole here, and we've got the curve matching the curve. And so I'm going to thread this through. And now I'm just going to line everything up. Bending this wire as I go, fitting this into the slot it was obviously born to fit into. And notice we've already created what's going to be called our actuator resting post. Now we put 2 screws in, 1 2. We're going to use our power drill because we have one, but obviously any Phillips head screwdriver will work. We screw this down. We screw this down. Snug. Snug. And there you go. 2 wires, 2 contacts, and we've already tested and we believe these contacts are good. Okay? What we need to do now is make the battery contacts. This one is almost there. The battery is going to be going in this way with the larger minus going into the larger loop here.
So minus towards cam.
Minus towards the cam, that's right. Incidentally, if you were to reverse that, the only thing that would happen is the cam would go in the opposite direction and it doesn't matter. Okay. But there is a right and a standard way. But we need to position this so it's going to make contact with the motor in a firm way. So I'm going to bend this flat, and I'm going to bend this so that it will point forward into the middle of the motor contact. Okay. And now that I've got that, I can cut this. And part of the beauty of this evolved over an embarrassing amount of time is that this is now a spring that will maintain a good contact. Yeah. Okay, we're going to do the same thing symmetrically on the other side. This one will be a spring battery contact at one end and a actuator button, or the beginning of an actuator button at the other end.
You're just straightening it out?
Just straightening it out. And here we go.
Paperclip number 3.
Paperclip number...
Is it 3? Yeah.
3, correct. Okay, so we want enough to make a symmetrical thing. So let's make our symmetrical thing. That'll be fine. Then we go...
You want to have it in there long enough.
That's right, long enough to bend forward and enter this contact. So that'll be enough. Because you can see the well for the other contact is all the way over here. We take the subway.
Okay, so there's a little channel for that.
Yep. Once we see the subway, we say it's going to want to bend like this. I put a bend in, and then I make it go through. And I say, nice. And then if I just want to secure it a little, I can temporarily pull it and bend it, and now nothing's going anywhere. I can finish this.
So we're making the plus battery
contact, correct. I can bend it like that. That looks about right to me. And I can now line this up. One pointing into one hole. This one wants to be so that it gets there. One going into one hole, the other going into the other hole. So we're twiddling these to make sure that they're going to line up with the contacts. That looks good. We press it forward, and with one thumb on top and one thumb pressing it forward, we press forward and it'll snap down.
Tight fit.
It's a nice, snug, spring-loaded fit. So that's not falling.
All right.
And now, if you've been paying attention, you might predict that when this touches this, the motor goes. And you can see that this guy comes close to the motor. It's okay if it brushes the motor, but its job is to come close. So this is going to become the push button. But first, we need to add our last paperclip. All right, so this one, we're actually going to take advantage of this nice bend in the paperclip. Okay. So we're going to only...
So this time we're not bending all of the paperclip.
We're unbending the skinny
leaving
loop.
One part unbent.
Right. And I'm saying that looks good.
Right. So...
And that is going to want to go in this hole, like that. And it's
the hole right next to the cam.
the next to and at the bottom of the cam. And you may notice that the cam is activating a little bit, because if this connects everything, but that's not our goal right now. So I'm actually going to take out the battery so it doesn't.
So we're not ready for it yet.
Right. I'm going to line this up so it is in fact touching the resting bar, or the cam in this case, given the posture of the motor. And this guy is going to go down through the very same elevator that this guy came up through. So here also, that's right. So I bend it. This doesn't have to be this long.
Touching each other.
We are, in fact, we want them to touch each other. What we also want, by the way, is this vertical post here. And I'll explain why. So I'm going to just bend this here at this point. And now I'm going to secure that with a small screw. And so what this is going to do is going to connect these two different actuators to the same positive ground element. And to do that, I would like a small Phillips head screwdriver, just so you can see what's going on. It's helpful to position the screw this way. I've got this vertical post here. Now I'm getting this thing in here. And I'm screwing it in.
Just make sure that they're stay in contact with each other.
That's right, which they're in the same channel, and this screw is now coming in quite tightly. Okay. Okay, so remember I argued that I wanted this here, and the reason I want it is because I call it a joystick. We can use it for fine-tuning this thing later. Now we look at this and we say, all right, in principle, this, which is redundant, but we use it as a fitting wire. If I put the battery in, the motor, in this case, I predict will not go because this isn't touching this and this isn't touching this. The reason this isn't touching this is because the cam is holding it out. So I line these up, I slide this in, nothing happens. But now, if I press this, the motor starts, and this is where we want to adjust it. Once the cam is out of the way, I want this pressing against this. So now I'm going to take my joystick and I'm going to finagle it so that I can twist this. There you go. Okay. So now, here we go. A brief press and the motor starts. It needs a little more moxie here. I twist the joystick. We test again. That's it.
So you're adjusting how...
Right. I want this contact to press against the resting bar when the cam is out of the way. And that's what we've done here. So just to review, this starts the motor, the cam turns, it causes this to lay against the resting bar. That keeps the cam turning until the cam comes around again, pushes the bar away again, and it goes into rest. So it's a timing circuit. It's a logic circuit, and we are done assembling the chassis. We just look and admire our work, and everything is firm because the pressure and the angles are such that everything is sort of now held in place by the tension of the bends in the paper clips. Testing this is sort of a fine art. A voltmeter is very helpful, but typically we can find the problem by first actuating it, and if it doesn't go, then poking the various places with a piece of metal, and the one that responds to the poke is the one that was not a good enough connection. The cam actually has two functions. One is the logical function that we talked about before, but the other is its job is to crank the thumb. And so to do that, we have a coupler. The coupler is 3D printed plastic, but inside that 3D printed plastic, we put little paperclip loops.
This is more paper clips.
Yep.
Okay.
And the point is, when this metal screw rubs against this plastic a few thousand times, it can work its way through the plastic.
Yeah.
But it won't work its way through
Right.
the
This is a way of
paperclip
reinforcing
bearing.
it
That's right.
with some metal.
So that's a fourth function we've gotten out of the paperclip.
Right.
It's a bearing.
So yet another innovation, just using paper clips. And
That's right.
All
All right. So now I'm screwing this in to the second hole in the cam, and I want it in so it's just sticking out the other side of the cam. Okay. So the thumb snaps in with a great deal of vigor, but if you look carefully, you see that there are a couple of indentations which line up on these studs. And so if you line them up and then you push quite hard, it snaps into place. And that's not going to go anywhere. There's a right way to do this. You want this flat surface facing out. So we start by putting this like this. Now it's just in place. Now we're in a good position to put the chassis in the palm. It goes in tail end first, fits down. Now we want to attach the coupler to the other part of the thumb. You can see that they line up reasonably well. So we're going to take the pliers, and by the way, this is actually a nice trick. With one hand, you can hold a screw on a Phillips head screwdriver, and then you can use it. Again, it's nice if these things are lined up. All right. So we get this in place. There we go. Okay. And now this wants to be far enough to hold things, but actually does not want to be tight, because you want a fair amount of flexibility. Okay, cool. That was relatively painless. Now we're going to secure the chassis to the hand. And we snug it up, and now it's firm. And by the way, it is always rewarding and important to make sure that the motor still runs. Now we can put the spring into place. And we have found, there you go, that the spring is best done by putting it in this hole first, then bending it and squeezing it into the second well reservoir, which is there. Then if you press the belly, it'll snap in, and there you go. And now we should see, aha, there you go. Okay, so that was nice. Coupler, thumb, spring, and now we can do the push button. The push button has an out sticker which wants to be facing the palm, and it's got a hole which wants to capture the paper clip, and it just sits here. And you see when the back of the hand is in place, when you press this, it will activate the whole thing. So that's fine. This is firm, this is firm, this is working, this is not too tight. So now we're going to put the palm on, the backhand on the palm, Ultimately, this hole is going to line up to this. So we can start by taking this screw and getting it started. And we want to get it to where it's coming just to there. We have started this screw. We have it sticking out above the roof. We're going to put this in place. We're going to try to get this hole impaled on this screw without dropping the bolt. And I think I did. So now that it's lined up, I'm going to back the screw out. And now I'm going to take it forward, tighten this up. Good, good. This is in here. And now one of these. One of these. Snug. Snug. That's it. And does it still work? Yes, it does. Sometimes that push button sticks. But with a little wiggling, it unsticks. And there you have a completely assembled gripper hand, including the new compression spring, the snap-in thumb, and the push button. So we're going to talk about putting these grippy silicone rubber components onto the fingers. You can do this after the hand is assembled, but it's easier to do it before the hand is assembled. This is silicone tubing, and it is particularly well suited for a band that's going to go here on the thumb. Others on the tips of the thumb and the fingers. The others that we put on the tips of the thumbs and the fingers are actually silicone baby pacifier nipples, which have got very good qualities for this purpose. You can do that also for the one around the thumb, but for the one around the thumb, this silicone tubing is a little bit easier to work with because it has a larger diameter. So I'm just going to show the process. This is a tight fit, which on the one hand you want, on the other hand it makes it hard. We have found that this antiseptic gel is actually quite good as a short-term lubricant for putting this stuff on. So, and now I'm trying to keep my fingers from being lubricated, because the magic here is that the friction of the silicone on your fingers is really important. So I got that far. Now I need more friction because I got some of that stuff on my hand. But here you go. Step number 1 completed. Now, for the fingertips, it's a matter of cutting this. And again, a little bit of lubricant. A little bit of care to try to keep it off your fingers. And then you squinch it, you wiggle it, you twist it, you get it on, and you see the lubricant actually is helping a lot. All right, here I am holding it in place. Now, with my second hand, I lift this up a little bit. With my third hand, I try to get a drop of super glue in there. I have done. I woggle it around. You never want to touch the super glue with your bare hand. Using something like this in the way is a good way to do it. And you press and you wiggle, and then you be patient. And that will probably anchor this side down. While I'm waiting for that, I'm going to do the other side. Make a vent and an opening. Put in a little bit of super glue. Take this out. Push, squunch, wiggle, and hope for the best. Be patient. And that's how it's done. So we're going to repeat that for the fingertips. Not that you haven't already seen the essence of the issue. A little bit of lubricant. I'm going to start with the Easy Pinky. I haven't done this that many times, so I'm learning as I go. Woggle, push, it's much easier. Squunch, hold it down. Try not to poke myself in the finger. Give it a minute to evaporate the lubricant. Put in a drop. Wiggle and squunch. Do the other side. Open it up a little. There we go. Get that drop in there. Probably want to get really close to see what's going on there. But a drop did go in. I can see it dripping down inside. Now I take this out and I try to get it as far in as I can while helping the super glue grab. I think pressure helps activate the super glue. I'm not really sure, but anyway, there's the process. By the time you've pressed it, squinched it. So that's the story. And we will repeat that for all the other fingers. The end.